First example regarding logarithmic and exponential word problems: a radioactive substance decays in such a way that the amount of mass remaining after t days is given by the function m of t is equal to 23 e to the negative 0.0043 t, which is measured in kilograms. Find the initial mass. So this is an exponential function, as you can see, and we would like to solve for the initial mass. So that's how big is the object when it starts decaying. So anybody know what time we start at? Yeah, time equals 0. So that's initial means time is equal to 0. So I find m of 0, which is 23 e to the negative 0.0043 times 0. What is negative 0.0043 times 0? Well, it's anything to the 0. 1, and 1 times 23 will give you 23 kilograms. So it has an initial mass of 23 kilograms. Now it's going to decay, so that means you're going to have less material as time goes on. So how much mass remains after 21 days? What do you think I plug in? 21. So m of 21 is equal to 23e to the negative 0.0043 times 21. And for that, we're going to need to take out our handy-dandy calculator. What you got for Christmas? Because you were good. Santa didn't bring coal. 23 e to the negative 0.0043 times 21. So again, you grab e by doing second natural log. Just entered 21.01 days. I'm sorry, 21.01 kilograms. We're solving for mass. Question C, what's different about question C compared to B? You're solving for time as opposed to mass. So we need to start with a certain mass. If the mass is half the initial, what is the mass? 11.5. Yep. So the initial mass is 23. So the question is, how long does it take for it to decay to half its initial size? So when is this equation equal to 11.5? Half of its initial size. How do I solve that? Divide by 23. 1/2 is equal to e to the negative 0.0043 t. Prior to this unit, if you saw the equation, you'd be like, I have no idea how to solve that. But now you're super smart, and you know how to solve everything. What do I have to get rid of there? E. How do I get rid of the e? Natural log of both sides. So you got the natural log of 1/2 is equal to natural log of e to the negative 0.0043 t. And you know, because you're really smart, that those are inverse operations. They go away. The natural log of 1/2 is negative 0.69, which is equal to negative 0.0043 t. Divide both sides by negative 0.0043. Anybody? 161.2 days. Takes about a half a year. Kind of reminds you of chemistry class or something, huh? Raylan, would you like to share more? Okay, you sounded really excited. So. Are you gonna be a chem major? Oh, well, yes, okay. I thought you. I was like, I didn't peg you for a chem major. Okay, got it. All right. This is a great example. I like money. Raise your hand if you like money. Yeah, right now you put money in your savings account and you earn a whopping 0.1% interest on that money. Isn't that great? Doesn't even come close to keeping up with inflation. So after past 8 years, 10 years or so, especially when the housing crash happened, all of a sudden investments for obvious reasons just weren't going to build. So there's other places to put your money. You can put in the stock market, you can put in money market, different things like that. You could do long-term investments in the CDs and stuff like that. But the question is, what can you do with your money and how does it pay off over time? So I got $1,500 and I want to invest it. 8% is a really good rate if you could get it. Maybe you're going to invest in really good stock, you get a good return. But you can't ever go to the bank and get that. No way. So it's compounded semi-annually in the value of the investment after 5, 10, and 15 years. Now, this is a little bit different because I want you to look at these two problems we started out with. This one had an E in it. And the reason why is, as you look at your very initial problems here, we have this compound interest and we have this continuously compounded interest. Well, it doesn't have to just do with interest. It can go with growth or decay or things like that. But if you have, a substance that's decaying, you think it, stops every, say like, 19 days and say, okay, I'm going to decay a little bit more today. And then it waits 19 more and, okay, I'm going to decay a little bit more today. Or do you think it decays continuously? Continuously. And so you see when you have those situations that you have this type of formula. But when I invest money in the bank, let's say you get a CD, chances are it's going to compound interest, most likely say once every 3 years. That's often how they, 3-year CD, 5-year CD, something like that. And so if it's a very specific number, then you choose to use this formula. So as you can see, radioactive substance decays continuously, so it has E in it. But in this situation, $1,500 is invested at interest rate 8%, compounded semi-annually. So how many times during the course of the year? Twice during the year. So therefore, we use the first formula, not the second one. The amount at a given time is equal to the principal. Principal is the amount of your initial investment. Okay? That's your initial investment. That's what you put in at the very beginning. Times 1 plus the rate at which it's invested divided by the number of times that it's compounded in the course of the year, raised to that number of times the number of years that it's invested at. Good. Oh. Oh, okay. Never mind. You will get that equation. So you'll get that sheet of notes. So the amount after 5 years is equal to the principal, which is 1,500. Actually, I'm not even putting 5. We're going to use our table on our calculator, put in 5, 10, and 15. So we'll just use T. Amount at T years is 1,500 times 1 plus, what's the rate? 0.08 divided by 2, twice during the year, raised to the 2t power. So because I'm going to come up with 3 different values, I'm going to go to my calculator, and I'm going to type in y equals 1,500 times parentheses, 0.08 divided by 2 is 0.04, so I have 1.04. I'm going to raise that to parentheses, the 2t power. So important that you put the 2t in parentheses, otherwise it ain't going to be right. And then, if you remember, I did second window to get your table set up. Is your table set up to have an independent variable to be asked? If not, you might want to change it to that. So that way when I go to my table, I can type in 5, 10, and 15. And I get the amount at 5 years is equal to, very good, amount after 10 years is equal to 3,286.70. Amount after 15 years is 4,865. Better to use your table than to just plug it in 3 times, right? So I'm always trying to show you shortcuts, right? I don't show it to the other classes. Just you guys.
right, flip it over. So that was a question I asked of you kind of at the beginning of class, as you look at a mortgage rate, let's say it's 5% for a 30-year mortgage, or it's 4% for 20, what is your best investment over the course of a certain amount of time? And this is a good question. You would like to know this. Which of the given interest rates and compounding periods would be the best investment? Suppose you could go to the bank and get 6% compounded semi-annually, or how many times a year? Twice. Or let's say you get less of an interest rate, 5%, but it's compounded quarterly, or 4 times a year. Or suppose you get even less of an interest rate, but it's compounded an infinite number of times during the course of the year. Which one do you want to sign up for? You don't know. You're just making a dumb guess. 1, 2, or 3. You want 3? Who else want 2? Everyone 1? Oh yeah, everyone wants 3. All right, let's see. You'd want to figure this out. You'd say that the amount at a given time is equal to, we don't know the principal, so we'll use P times 1 plus, for the first one, 6%, so 0.06 divided by 2 raised to the t power. So I looked at that expression, and we compare it to the others. This one would be P times 1 plus 0.05 divided by 4 raised to the 4t power. And when we compound continuously, things change. We use this formula instead. Amount is equal to the principal times e to the rt. So let's see if we can do Alright, 4% compound continuously, so we got P times E to the 0.04t. Well, is it obvious to look at those and see which one is better? It's tough for me to see, so tell you what I'm going to do. Each of these has a P, and each of these has a T. So I'm going to make it so they each have a P and a T, and all the rest is just a number. So I'm going to take 1 plus 0.06 divided by 2, and I can use up this 2. I use up this 2 by squaring it. Take my calculator. 1 plus, or let's just be 1.03, right? 1.03, and I'll square that. I get 1.0609. So P times 1.0609 raised to the t power. So I used up the square. 0.05 divided by 4 is that, plus 1, and I'm going to raise that to what power? And I get 1.0509. So P times 1.0509 raised to the t power. And next one, what do I do? E to the 0.04, and I get 1.0408. P times 1.0408 raised to the t power. So now I can really compare them. Regardless of the principal, as long as they have the same principal and the same amount of time in which they're invested, which one is going to grow at a faster rate, the first, second, or third one? The first, the larger base. So it turns out in the situation to be best off with this example. Now that's because the interest rate drops each time. If this was, instead of 4%, or 6%, that would be different. I would say, why doesn't the continuously one end up working out to be greater? Well, because if we were to put in continuous number, yeah, we would, let's say it was 1,000,000 times that we were going to compound it. Well, not only are you taking to the 1,000,000th power, but you're taking that rate and you're dividing it by a very large number as well. So if it's smaller there, but bigger there. So it doesn't necessarily work out that it's always going to be the best option. Right. A man invests $2,000 in an account that is compounded annually at an interest rate of 5.4%. What is the amount of investment for 4 years? which equation are we going to use? The first one or second one? First one. So the amount after 4 years is equal to, what's this principal? 2,000 times 1 plus 0.055 divided by 1. It's compound annually, so it's just 1 time a year. Raised to the 1 times 4 power. Yes, t, but t is 4. So I'm just going to calculate that. Another 77.65. So, you can decide if he really wants to invest it for 4 years. He's got $500 more extra by the end. Is that enough? He's got to decide. Maybe he wants to spend it all on and buy something else. All right. My next question is more interesting. How long does it take for the investment to double? I'm solving for 5. How do I set this up? Very good. So 4,000 be twice investment. You say, yeah, I've got some money. I want it to double. How many years do I have to let it sit? All right. Figure it out. 2,000 equal to 2,000 times 1 plus 1.055 raised to what power? Raised to the t power. That's what we're trying to solve for is t. What do I do on both sides? Negative 2 is equal to 1.055 raised to the t power. Uh-oh. Confusing, brains exploding, don't know what to do. Everybody's from last year, shut down. Log base 1.055. Good. Log base 1.055. Because you learned that there's this wonderful inverse operation between logarithms and bases of exponentials. So those cancel, leaves you with t is equal to log base 1.055 of 2. And thankfully, because we have such a wonderful formula, we know how to solve for that. Take log of gross. That's not bad. That's not. I'm looking at your work, at your sports answer. So that's all for the now. I want to buy a car for $4,000. I only got 2,000, so I'm missing a break. So I got to wait for 13 years, I guess. Yeah, that's a lot of money. Somebody said that they're buying lottery tickets. You guys probably bought lottery tickets last week. And then they say, right. And I say, I win every time. Every time the lottery comes around, I save an extra buck. And I'm going to win. Yeah, like that one, yeah. I don't know what it was. It was fun. If I did win, after taxes had $400 million, would you guys expect a kickback? We were expecting a living like $100. Okay, what would be the reasonable amount? A grand, 100, a 10? You guys need some wine? Just why can you jig on the subway just to a 10? You expect a new teacher? Wow. Hey. If I won would you always respect like I was like I would just quit. I was like, I'm done. I'm done. Well, if you gotta get 2 weeks notice, tough luck. Okay. Keep on last question. Or would you think I was a little sour if I just up and quit? I said, at least finish the year out, right? Yeah. Yeah, you're right. That's my motivation is to live my paycheck. Because I love you guys. Right. The best thing stop picking it. The best thing of $800. Compounded quarterly over the course of 6 years. Reduced investment resulted in that number. What was the interest rate of the investment? Oh, let's keep changing the problems on us. What are we trying to solve for here? A variable. Uh, power cholesterol. I can't do it with those variables. I'm going to do some stupid thing. It's going to sit right here for you. Alright. Alright, so, alright, so we got 1,245.83. We're going to use the first one, the second one. Second one. We got the first one because it's not continuous, so we got quarterly. Equals what's principal? 800. And it's times the 1 plus divided by 4 raised to the 24th power. Alright, alright. Alright. Why is that? Right, right? Right. So we take 545 divided by 1.56. Yeah, plus. Alright, 3 is the 24th power. Number of years 6 times the number of times that it's compounded over the course of the year. So it's 1.5. This part right here is 1 times 2, so 4 times 6. Okay? So we have to get what are the three numbers off of what we have to decipher now? 1, 4, and 2, 4. What's the first one we got to do? Ready? Love it. Love it. I love it. Tell me what other. Right. It's, we always go back to this idea of log of an x squared. Oh, very careful. Yeah, that's a log of it. I have a log of it. That's all I know. I love it. You guys are going to do this. You're going to start solving equations like x squared. Oh, that's pretty cool. Oh, 2x. All right, we got it. Take it back. So what I did, I went through the There we go. What'd you say? Say that, Rob. What'd you say, Chad? What's your quick one? All right, Franklin. Right. So think about it. If you had h is equal to x squared, what would you do with yourself? Square h is taken it to what power? The reciprocal power. So if you want to get rid of an exponent, you raise it to the reciprocal power. This is kind of cool because it almost taking it to the 1 over 24 power, isn't it? So first time for everything. Big deal. Yeah, you're welcome. All right, so we got 1.056. 1.56 to the, that says 1 over 24. you don't know where it started at the very beginning. And notice that this equation does have an and, right? Because again, it's continuous. It's always so it's equal to over 1 plus r times x negative 24 times 0, right? Including zeros at the end. So the 4 over 6 because so what is it? So the 2 is cut and there's a 0. The negative 24 times 0. So what do we define the first size of the number? What is it? That's the numbers that we started with, right? That was the first one. What's the difference? What's that happening? The population that's a good band. What's that? You did pretty well. Yeah, so maybe five polarities there. The only one that matters is right. What is that? Yeah, so it screams out ability. You just say, yeah, it's bad. Yeah. Yeah, population continuous. So we have infinity over 1 plus times x negative 24 times 10. Negative 3. So this is so let's say for the purpose, right? This is equal to we take the development of so minus the two expressions. Is that plus? So the fraction is a negative minus the fraction sign. And just take the negative. Anything else? Let's go back and try. So same as it's just right? Population is going up. At some point it's going to drop off, right? Yes. It's good to really write something else. Some math, just advanced or just lots of selection math. So there's a lot of different techniques we can use. Popularities is perfect. It's positive, right? Number of most people is going up. Yeah, 0 to 10 because this equation is going to replace the 10. Take the expression itself as the 10. All right. And here we got big numbers going on. Right? Okay, 2 options, just four functions. We say it all the way through. So give a class notes for me. Class notes for this is pretty interesting. I feel like I should have here before. So check out the database here. And yeah, definitely. It's okay if you just take the simple database here. So we've got right, plus right, right, over 30 over 1 over 8. Want to get rid of the 30? Okay, so negative 30 over 8, right? Over 8. That cancels out. So 1 plus r 8 over negative 0.32 equals to 2.551. And 8 over negative 0.32 equals to 0.75. Right? And over negative 0.32 is equal to 0.14. Lots of answers are going to get rid of the base of 30.